So in this video, I do want to talk about temperature. So if you remember, our SI temperature, or our SI unit for temperature is Kelvin, and then many of us are probably used to reading temperature in either Fahrenheit or Celsius. So I want to spend a little bit of time going through the 3 different temperature scales and then converting between them. So 3 temperature scales. Our first one, Fahrenheit, which is a difficult word to spell. So degrees F. Our second one, Celsius, degree sign, and then a capital C. And then our third one, Kelvin. And if you remember from the first video in this week, this one we don't actually put the degree symbol, so just a capital K. So degrees F, degree C, and then a capital K without the degree symbol. Remember, Kelvin is our SI unit for temperature. Celsius is, if we were in lab this semester, that would be what we would be measuring temperature in, and then converting between Celsius and Kelvin is a calculation that you're going to do often. Fahrenheit we're hardly ever going to use, other than use it to compare to Celsius and Kelvin. So the way I want to do this is I'm going to draw 3 thermometers, and they're actually just going to be straight lines, but we're going to kind of compare and contrast here. So this one is going to be Fahrenheit, this one in the middle is going to be Celsius, and then Kelvin over here. And then we're going to use the freezing point and the boiling point of water as our baseline. So freezing point of water is going to be the bottom, and then the top, boiling point. So let's do Celsius first, so the one in the middle. So what is the freezing point of water in the Celsius scale? Yeah, hopefully you guys said 0 degrees. Or thought 0 degrees. And boiling? Yeah, good, 100. So Fahrenheit. Freezing, yeah, 32. How about boiling? Not everyone knows that one. Yeah, if you came up with 212, good job. If you didn't, it's 212. So if we were to count the number of degrees between the freezing and boiling point in the Celsius scale, we would end up with 100 degrees, right? If we were to put a little tick mark, every degree there would be 100. And if we were to do the same thing on the Fahrenheit scale, right, I'm going to take 212 and subtract 32 from it, I'm going to get 180. So what that means for us is that 1 degree Celsius is not the same as 1 degree Fahrenheit, right? If my temperature is going to go up 100 degrees on the Celsius scale, it has to go up 180 degrees to get to the same point on the Fahrenheit scale, right? If I was to make a ratio out of those, there's 180 degrees Fahrenheit for every 100 degrees Celsius, right? A Celsius degree is bigger than a Fahrenheit degree, right? For every 1 that I go up on the Celsius scale, I have to go up 1.8 on the Fahrenheit scale, right? If we reduce that, 1.8 degrees Fahrenheit for every 1 degree Celsius. So when we're comparing and we say it went up by 1 degree, it really depends what scale we're talking about, right? Maybe it's 1 degree on the Fahrenheit scale, it would be less than 1 degree on the Celsius scale then. So we do need to be specific if we say 1 degree as to what scale we're talking about. The other part, if we're converting between them, is our starting points, right? Fahrenheit, we're starting at 32. I know it's a weird number. In Celsius, this is why we love the metric system, it's starting at 0. So if you're converting from one to the other, not only do you need to take that 1.8 into account, but you also have to take into account the fact that they start at different places. So converting between the two, if I know my temperature in Celsius, and I want to convert it to Fahrenheit, I'm going to have to take that temperature, I'm going to have to multiply it by 1.8, right, to account for the fact that each degree is actually a different size. So 1.8 multiplied by that temperature in Celsius. And then since it's starting at 32 instead of 0, we're going to have to add 32 to it. And that's how we would convert from Celsius to Fahrenheit. Now, the book shows the formula a little bit different. Instead of doing 1.8, it's actually using 9/5, right? We could reduce 180 divided by 100 down to 9/5 if we want. So our text, if you look up the formula there, is going to do 9/5 times our temperature in degrees C plus 32 degrees. To me, that's just more awkward to type into my calculator, so I use 1.8. Either version will work, though. It's, 9/5 is 1.8, so either version. So this is our temperature for converting between the two. Going back up and looking at our Kelvin scale, we're going to do a similar thing. What's my freezing point in Kelvin? Do you guys know this one? If you had chemistry before, you might know. Yeah, it's 273. 0.15, if you just remember the 273 and forget the 0.15, I'm actually fine with that. How about freezing or boiling? Yeah, 373.15. So if I look at this one, subtract 273.15 from 373.15, I get 100 again. So what that tells me is that 1 degree in the Kelvin scale is the same as 1 degree in the Celsius scale, right? If I want 100 degrees on one scale, I go up 100 degrees on the other. So those are the same, right? If we go back down, we could say that 1 degree Celsius is equal to 1 Kelvin. Again, no degree sign for Kelvin there. So converting from one to the other is easier, right? I don't have to take into account the fact that the degrees are different. I don't have to multiply my temperature by anything. The only thing I have to do is add, because they do start in different places, right? Celsius starts at 0, Kelvin starts at 273.15. So we just take our temperature in Celsius and add 273.15 to it. So my temperature in Kelvin is going to be equal to my temperature in Celsius plus 273 or 273.15. I honestly am not particular. And then backwards you would subtract, right? So my temperature in Kelvin minus 273.15. Those are two formulas that I do want you to know. We're going to be converting between Celsius and Kelvin pretty often, and it's just going to be faster if you don't have to look them up. So if you just remember 273, just add it to your degree, your temperature in Celsius to get Kelvin, and then subtract it from Kelvin to get Celsius, and you'll be fine. The ones between Fahrenheit and Celsius, I'll give them to you if you need them. You don't need to memorize those. But I do want you to be able to explain it. Like, I am way more likely to ask you on a test or a quiz why we're multiplying it by 1.8 than to actually have you multiply it by 1.8. So do understand it. If I ask you, you can, by all means, draw me a little picture like this, right? And say, show me how 100 degrees on one scale is equal to 180 on the other, that sort of thing. I didn't bring any practice problems because the math is pretty straightforward. So there are some in your text, so please practice them if you feel you need to. Again, do know the conversions between Kelvin and Celsius.